So one of my favorite things to do with circuits is to anthropomorphize the little charges and kind of imagine myself as a little charge in the circuit. So I am living inside of this circuit, and I know there's some potential differences here and there. And what's actually going to happen is that potential difference that the battery creates is going to create little tiny electric fields that live everywhere inside the metal. I'm a positive charge, so that electric field is going to push me one way or the other. And so I'm going to move clockwise for this particular circuit through the whole piece of metal. And I'm going to try to go all the way around if I can. But all the other little positive charges that live in the circuit are also going to react this way. Everywhere throughout the circuit, there'll be a little electric field, and these little charges will get pushed along. And so what will happen is a whole bunch of charges are going to flow together through this circuit. And that flow is a thing that we will call current. Now, many of you are probably familiar with current, either from a previous class or just from your everyday life. But the definition that we will use for current in this class, whenever I say current in this class, I mean electric current. Electric current is the flow of electric charge. In particular, it's a time flow of electric charge. The specific definition you see down here is actually a derivative one. We've seen a few flows before, especially like velocity, right, is dx dt. That's the same kind of structure as we get here. So the current, which we'll use capital I for the current, is equal to dq dt, which you can think of as a little amount of charge, dq, passing by a point in a little amount of time, dt. The unit for current, as you can kind of see, is going to be coulombs per second, which we will rewrite as amps.